Okay, we'll start section 9.3. So this is the next brand new section. 9.3 is titled the integral test. Starts on page 609. An integral test. It might read a little bit like gibberish. It's not that hard to figure out. Taking f to be a positive function, continuous and decreasing for numbers bigger than 1. We're taking terms off. A n is f of n. The conclusion is that series, sum of a n, either, and the integral from 1 to infinity, either both converge or both diverge. Alright, this builds off of section 8.8. In 8.8, we found, we took integrals from 1 to infinity of f of x dx, which is the area under this curve out to infinity. We call them improper integrals. If that area was finite, we said it converged. That meant the f gets small enough, close enough to the axis to pinch off, give you a finite area. If that area was infinite, we said it diverged. This theorem, 8.8, says to take integer values from 9.3, this theorem from 9.3, integer values off of f of x. So at integer x values, the y values, the f of x values, a1, a2, a3, a4, and add them up. Does it not make sense that if f of x gets small, then small enough to converge and have a finite area, then the a1, a2, a3, a4 will be small enough to have a finite sum. So if the area is finite, integral 1 to infinity f of x dx works out finite, so that this converges, then taking numbers off of a converging curve, summing them up will also add to a finite sum. My note, my writing got a little tight at the bottom here, but numbers off of a sum small enough to give a finite area will also be small enough to add to give you a finite sum, so that this integral and the sum will behave the same. If the area is infinite and diverges, then taking the sum of the terms off of a diverging curve to give you an infinite area here, these individual values at integers will be too large, will still add to an infinite sum, and therefore this area under this that we did in 8.8, when I add up numbers off of the f of x curve, that sum will also be infinite. I think that my part 1 is over, and we'll pick up with part 2.